Hello and welcome to my channel. Today we are going to learn how to use test containers in Spring Boot application tests. So you have a Spring Boot application like mine here. Mine is connected to a local PostgreSDB and has two endpoints, a get and a post for a pet resource. Like the good engineer that I am, I want to write test cases to ensure my application runs as expected in production. So I have a test case that I've written here. I have a test class here. The first test case use mock MVC to make an actual HTTP call to the post endpoint, as you can see on my screen here. This is just like a production user would do. The second test case ensures that if a pet record exists, when I call the get endpoint, it will return all the stored pet records. I am going to run this test quickly. All the tests passed, which is good. If you notice, these tests are running like in production. There is no extend with Mockito extension annotation on the class. There are no @mock annotation anywhere in the code base. The tests are running, and this is good, but we have one challenge. The tests are running against my local PostgreSDB. If I stop my local PostgreSDB and run the test again, the application won't even start because it needs to connect to a database. Let's just say that. Stop, run the test again. So you can see the application is not running. And if we go to the error message, you will see that it's because it's attempting to connect to a PostgreSDB that is not available. If I mock the database layer, I will not be able to test things like database constraints, logs, transaction rollbacks, and all other native database behaviors. What if there is a way for me to create a temporary database and delete it once the tests are done? This is why test containers was invented. TestContainers is a library that provides disposable databases, RabbitMQ, or Redis Docker containers. These containers are automatically created when the test run starts and destroyed when the test run ends. So let's add test containers to our code base. Step 1, you need to ensure you have Docker running on your local machine. If you don't have Docker already, please go ahead and install it. Now we can go to step 2, which is adding test containers dependencies. So we go to our pom.xml file and we will add the dependencies that are required. The dependencies I've added here are the JUnit library, the Spring Boot test containers, and the Postgres module. I am adding Postgres module because my application is connecting to PostgreSDB. Now that we've added the dependencies, let's configure it. First, we need to create a application test.properties in the resource folder. So I'm going to go into the test resource folder, create a new file called application-test.properties. In this test properties, we will override data source connection string, username, and password. The URL is slightly different from the regular one. If you compare the URL, the JDBC connection URL, with the one in the main application properties, see there are some differences. Let's go back to the test URL. The presence of TC in the URL is the trigger point for test containers. Following the TC is the Docker image name to use and the Docker image tag. Once the application is starting and test container sees this special URL pattern, it will pull the Docker image from Docker up, create a container for it, expose a random port, then hand this over to the application for use. Now, after this, every database interaction will be happening with a real database that is running as a Docker container. It is as simple as this. This is simple because Test containers is deeply integrated with Spring Boot testing infrastructure. Finally, let's activate the test profile on our test by doing active profile test so that the test configurations will override the equivalent in the main configuration. Now we can run the test again. Notice I've not started my local Postgres. I'm just going to run the test as is. And waiting and running. Voila, the test passed. If we look at the output console, we will see logs indicating test container starting up and also creating the required container that we need for the test to pass, specifically the Postgres container. If we just scroll down, we can see the Postgres container starting, right? You can start using your database server. The database server has been started, and so on and so forth. And this is how to fully test your application in Spring Boot with the help of Test Container. What if I want to connect to the temporary database created by Test Container? This may be to debug issues or inspect the schema. There's a little trick we can do. We can add a breakpoint to a method here. And with the breakpoint at the method, we can run the test in debug mode. Not the regular mode. I'm going to run the test in debug mode. Now, as you can see, the test execution has paused at this breakpoint. This will give us time to inspect and connect to the container created by the test container library. So from IntelliJ, I'm just going to go to the database. I'm going to add a new connection, data source. I'm going to do Postgres. I'm going to do localhost. But before I do that, I will need to pick the port generated for the PostgreSQL by test container. So I will go to console. I'll go to the main one. I will just search for JDBC, and there it is. This is the URL. Container is started, JDBC. So I'm just going to pick the port, and then I'll come back again to add a new data source, Postgres, localhost. I'll do port. Test container always use the test as the default user and test as the default password. So we change the database to test containers demo, as we can see. Then I can test the connection, and you can see succeeded. So I can apply, click on OK. Now I'm able to connect to the database that is created by test container, right? So after you have connected to it, you can connect to it using any other database client of your choice. After connecting to it, once you are done with your debugging, I can resume the test here, and everything will run as expected. Of course, this is a fancy way of doing it. Another way of doing it is you can just come around the hard thread.sleep and sleep for a really, really long time. You will still achieve the same effect. The main goal is that we are able to pause the execution. Beyond connecting to the temporary containers, we can also do things like inspecting the container itself. If you have Docker Desktop installed, you can inspect the container. You can connect to the bash and execute whatever script you want just for debugging purposes. Can I use private Docker repository? One way to achieve this is to create a testcontainers.properties, and in it, we will have the property ob.image.name.prefix that will be the URL of our private repository. So let's go ahead and do that. We can create new file, test containers.properties, and then we can add ob.image.name.prefix. We can add there. Here, I'm just going to use docker.io for example. Whenever we do this, test container will pull image from this particular Docker repository, Docker registry, that have been specified. Remember, because this is a private Docker registry, remember to log into your Docker registry. You can use the command docker login, docker login, the Docker registry URL. In this case, I'm using docker.io, -u, your username, and then you press enter. It will ask for your password, and then you can input the right password and you will log in correctly. If you do not do this, Docker test container will not be able to pull the image from the private Docker repository. Let's say you want to authenticate to the Docker in a pipeline, right? So you can also use the alternative one where you say Docker login, the Docker registry, -u, your username, and then you can use -p, which is for password, and then you can use a variable name, Docker pass. This one will exactly authenticate you as well into the private Docker repository. Now, in order for our test to run successfully in a CI/CD pipeline, we need to ensure that Docker is available in the pipeline. Remember, the prerequisite is that you have a Docker running on your machine that the test is executing from. That same rule applies to CI/CD pipeline. Some CI/CD providers like GitLab will call this feature Docker in Docker service. So I highly recommend that you consult the documentation of your CI/CD provider to find out how to avail a Docker environment when your test is running. For the purpose of this tutorial, I'm using Circle CI, and if I go to the config file, all I need to do is add an extra step called setup remote Docker, which I'm just going to do now. You can say setup remote Docker, and once I do this, Docker is going to be available on my pipeline. This is all I need to do for my test to run in a CI/CD pipeline where Circle CI is the provider. So what I'm going to do now is just to commit my code changes, and I'm going to push my code to the cloud, and then we'll go ahead and see how Circle CI is going to run this in the pipeline. We can see that from the test case here that Circle CI is running, so we can just go ahead to go to the Circle CI to see. You can see that our test is running already on Circle CI, right? Thank you for watching. Please like this video and subscribe to my channel for great tutorials like this one. TestContainers has other modules, right, like RabbitMQ, Redis, LocalStack, Kafka, etc. In essence, instead of mocking those external dependencies, those resource dependencies, your application, I encourage you, I recommend that you adopt TestContainers for your own use case. The complete source code is available on GitHub, and the link will be in the description below. Love this tutorial? Please subscribe to my channel. I really appreciate the support. Thank you.